Trigonometry, the tan ratio. So far we have looked at both sine and cos ratios and how we can find missing sides and angles using them. Today we're going to be having a look at the tan ratio, and it's going to work through in exactly the same way. So again, it can only be used with right angled triangles, and again the ratio looks very similar. So tan theta, remember theta is our angle, is opposite over adjacent. And if we think about the other ratios we've got, or already seen, we've got sine theta equals O over H, and cos theta equals A over H. So sine doesn't include the adjacent side, cos doesn't include the opposite side, and tan does not include the hypotenuse. So that means that as long as you have one angle and two sides, with one of the three things there you're trying to work out, you can use either tan, cos, or sine. Again, as per usual, we have our formula triangle we can use as well. So tan theta is opposite over adjacent. Now, I know that if you've watched the previous two videos and understood them, then you will be really good at doing these triangles now. So we're going to jump straight into it. And the first one we're going to have a look at, again, right angled triangle. We've got x is our height there, we've got an angle of 20 degrees, and this side along the bottom is going to be 7 meters. And we're going to follow our 5 steps we've been doing so far. So the first one, we need to label the sides of our triangle. Now normally, I've been saying we need to do the hypotenuse first, but we're not interested in the hypotenuse. It's not labelled, it doesn't say anything on it, we're not trying to work it out. So I'm going to put a little h, but really we're not worried about it. Then we would have our opposite side and our adjacent side. We've got O and A, so we're looking at tan. Now we need to write out our equation. So we're trying to work out what O is. So O is equal to A times by tan theta. And again, I've put the letter before the tan theta. It doesn't matter which order really, but when we put it into a calculator, it just makes life a bit easier. Third step, we need to substitute. So x is equal to 7 times by tan 20. Step 4, we calculate. So you need to find a calculator and put in 7 times by tan 20, which will give you an answer of 2.55 meters to 2 decimal places. Be really careful, make sure you put the unit on there because it says meters over here. We need to go with meters again. So x is 2.55 meters, and step 5 is to check our answer. Does that make sense? Well, if this side here is 7, then 2.5, that's in the same sort of ballpark. If it was, say, I don't know, 100 meters, and then looking out at 1 meter, we might be considering, okay, have we got a really small angle? But here, it's very close, so we're happy. Okay, second example we're going to have a look at. We're going to go through the steps again. So step 1, label the sides. That is going to be our hypotenuse. We've got our opposite side and our adjacent. O and A, so we're using tan. Write out the equation. So tan theta is O over A. Substitute. Tan theta is 4 over 3. Now we need to calculate. So we're going to do theta is, not sure what happened there, the inverse tan or arctan 4/3. Put that into your calculator. You should get an answer of 53.13 degrees. 2 small places. Step 5, we need to check our answer. So if we have 53.13 plus 90, that is 143.13 in total. There's still room there for the third angle before we meet 180, so that makes sense. Okay, now it's your turn. So here are 6 questions for you to have a go at. Pause the video here, give them a go. Your aim is to work out either the angle theta or the side length x. Use the examples to help you, and then come back for the answers in a minute. And these are the answers. So question 1 is 45 degrees. Question 2 is 60.26 degrees. Question 3, the side is 2.96. Question 4, 4.82. Question 5, 21.62. And question 6, 6.79. I hope you found this useful. Thank you very much for watching.